So AP Calculus AB, this is a kind of a strange problem. We're asked to find the volume of a solid whose base is bounded by y equals 0 and the curve y is equal to 4 minus x squared. This is the part that you just have to notice this on the exam. It says whose cross-section is taken perpendicular to the x-axis are semicircles. So this is what I want to tell you. When you see something like this, you see this, and you see solid, you start thinking this, that the volume is equal to the definite integral a to b, and we'll find that integral of ax dx, where a is the shape that we're interested in. Yeah? So this is what we have. Let's take a look at this really quick. So our graph looks like this. Right? Our graph looks maybe like this, like that, right? And then also we said here that it's bounded by y is equal to 0, so that's here, right? So what we're looking for is this here. This piece right here is what we want, right? But now what we're going to take is we're going to take semicircles and put it on top of it. So semicircles, so I'm going to lay the semicircle straight down. So here's the semicircle right here. Here's what my semicircle looks like, kind of like a protractor. But if you look down on it, you'd see that, wouldn't you? And this blue piece right here, Danny, would be right here, right? And then it's going to be a bunch of those things. So that's what I'm going to start to build here. So I think that the volume is equal to, and we know that these intersections are -2 and 2, aren't they? So from -2 to 2 of, and we have at the top, we have 4 minus x squared, right? But remember, we have to do this at the bottom also, just in case it wasn't 0. This one down here is 0, isn't it? So this minus 0, right? And then we have of a semicircle, so I should have done that, right? I should have squared this, right? So let me go back and clean this up a tiny bit, right? So I had 1/2, right, pi r squared, and r was the function 4 minus x squared minus 0, right? Squared. Check this out for a second. This kind of caught me just for, and I have my dx out here. This caught me for a second. Look at this for a second, Danny. If I put this semicircle here, right, and I go from here to here, this distance right here is not a radius, it's a diameter, isn't it? Because its radius is halfway, right? So it'll be here. So you have to divide this by 2. That makes sense? And from here, I think it gets pretty good. I'm just going to take 1/2, right? And then, actually, I'm not even going to do anything here. I'm just going to put this into my calculator and get my answer here. I really am. I'm going to put this straight into the calculator. What I want you to know is this. What I want you to know is that, first off, you have to know this theorem right here. But when you see something, find the volume of the solid formed, and you see something about it's a base, then you have to start thinking about going to here. All right?